So we are on 219, topic 3, long and synthetic division notes, period 1. And I thought I'd just start with a quick review of stuff we've talked about and stuff we're going to work towards. As I said, all of these topics come together. So on the first slide, I'm giving you two functions, and those functions are in what we called factored form. Okay, so these are in factored form. Factored form. In factored form, you can easily determine the zeros of the polynomial because all you have to do is set each factor equal to 0. So x minus 1 equals 0 and x plus 3 equals 0. Okay, that means I have a 0 at 1 and I have a 0 at negative 3. I'm going to come down here to my graph. A 0 at 1, 1, 2, 3, and a 0 at negative 3. Now we know that that translates into the x-intercepts. So my x-intercepts are negative 3, 0, and 1, 0. Then I need to determine the degree of this polynomial. Now, when you're in the factored form, the degree of the polynomial is the sum of the exponents on the factors, right? So let me write that up above. It is the sum of the exponents on the factors. So in number 1, 2 is the exponent on the factor x minus 1. And 1 is the exponent on the factor x plus 3. So this is actually a degree of 3. If we were to multiply out this polynomial, we would have a negative lead coefficient. Because you see that negative out front of the x minus 1 squared? That would mean that the first term of this polynomial, when you multiply it out to standard form, which hopefully you practice that in Delta Math, you would get a negative. Now, why do I have to know that? Because the degree and the lead coefficient tell you about end behavior. So this is a cubic function that is reflected from its parent form. If it helps, graph it before you look at your end behavior, all right? So my polynomial is going to start up here, all right? It's going to come down, right? Now, at some point, it has to go through the y-axis, y-intercept, right? Oh, I haven't figured that out yet, so let me go ahead and do that. So y-intercept, okay? So that's going to be negative and then 0 minus 1 squared and then 0 plus 3. Okay, negative 1 squared is a positive 1, but then you're going to take it and multiply it by the negative. So that's a negative 1 times 3 is negative 3. So, oh, hey, that makes sense that the y-intercept is 0, negative 3. Okay, so I'm coming along, right? I know that I have to go through the 1, right? So, but at this point, what do I do? This is where end behavior comes in. I do not go through the x-axis because then it would look like an even degree polynomial. And this is an odd degree polynomial. And so in math, we call this bouncing off of the root, bouncing off the root. So we bounce here because, and then here we go, multiplicity is 2. What do I mean multiplicity? Multiplicity is the degree of the factor. So that factor x minus 1 squared, right? That's x minus 1 squared, has a degree of 2. We bounce. Now, you're probably thinking, why do I care about all of this when I can just put it in Desmos, right? Well, normally we have a no calculator or a no technology assessment. What's up? And we don't this time, right? So what's it going to look like on your assessment? Well, on your assessment, I'm going to ask you to explain using the microphone, right? It's probably going to be a take-home assessment because I don't want people that are in the building to have to worry about recording. And most of you are home anyway, so take-home is just home. And have you walk through and explain. Feel free to check your work in Desmos, but you will have to explain, why does the graph start in the second quadrant up there? Because it's a odd degree with a negative lead coefficient. Why does it go through -3? Because that's an x-intercept. That's a 0. Why does it go through 0, -3? Because that's the y-intercept. Why does it hit at 1 but then turn and go back? Why is there a relative min, or excuse me, a relative max at 1, 0? Okay, so that's the sort of things that you're working towards. So end behavior, oops, usually I have it written for you, but I'll write it as f of x goes towards infinity, right? So, no, sorry. As x goes towards infinity, f of x goes towards negative infinity. Let me get that negative in there. So as x gets bigger, look at where the function is. It's pointing down. It's going towards negative infinity. As x approaches negative infinity, so as I look left, f of x is approaching positive infinity. All right. And so I just grabbed this as a quick review of us talking about the things we've already worked on. Okay. Today's lesson is going to seem a little detached until we bring it all together next week. All right. So slide 2. Here is a little graphic that I found on the first thing I'm going to go over, which is polynomial long division. So this is just something for you to look back at, which goes through the steps of polynomial long division, all right? And on the next slide, I'm going to actually show you, all right? So let's talk about long division. The process of long division for polynomials is the same as when you do it for numbers. So in that first example, 4 divides into 126. 4 divides into 12 3 times. 3 times 4 is 12, and then you subtract. Then you bring down the 6. Hopefully this looks familiar. 4, whoops, I just moved the slide. 4 divides into 6 1 time. 1 times 4 is 4. The remainder is 2. How did you first learn to write this? Well, 31 and 2 over 4. So that remainder divides the 4, and you would write that as 31 and 1/2. Now that process is exactly what we do with polynomials, right? But we have to remember those rules of exponents that we did the other day, because that's part of the process, right? So let me do it with the x divides into x cubed minus 2x squared plus 7x, all right? So this is the new stuff, you guys. So x is going to divide into the first term only, okay? So x goes into x cubed. Now you think, what does that mean? Well, I take it the other way around. I take x cubed and I divide by x. You could have done the same thing in my first example. 12 divides 4 is 3. So how about we do x cubed divides x is x squared. Now we multiply. X times x squared is x cubed. We subtract. So x cubed minus x cubed is 0. And then we bring down the next term. So instead of bringing down the next number, you bring down the next term. Then I do the process again. So instead of thinking x divides into negative 2x squared, because that can be confusing, I take negative 2x squared and divide by x. And that's negative 2x. And so you multiply then x times negative 2, negative 2x squared. And then you subtract. Now, that gets a little complicated when you have all those minus. So negative 2x squared minus a negative 2x squared is going to be negative 2x squared plus 2x squared. And so they're going to zero out because we're subtracting, right? Sometimes you'll see it where teachers add the opposite. So they change that bottom term to a plus or minus, depending on what it was originally, and then they add. Okay, so bring down the last term is 7x. 7x divides x is 7. 7 times 7x is 7x, subtract. Remainder is 0. So that means my answer is x squared minus 2x plus 7. Now, when you're dealing with numbers, you know a way to check it. Like in the first example, I could have done 31.5 times 4, and I would get 126. For the second one, I could check it. If I take x and I multiply by x squared minus 2x plus 7, I'm going to get x squared minus 2x squared plus 7x. Okay, third example. So in the second example, we had a single term dividing into a polynomial. In the next one, we have a binomial dividing into a polynomial or a trinomial. Here's what we do. We still only do this one divided into that one. So we're still looking at the x and the x squared. So x squared divided by x is x. But when you multiply, you're going to multiply the x times the x and the x times the 1, and you're going to place them under their like terms. So x times x is x squared, and x times 1 is 1x. Now, we subtract, right? So we're subtracting. So x squared minus x squared is 0. 3x minus 1x is 2x. And then you bring down the minus 4. Now again, it's going to be x divides into 2x. We're only looking at the first term of each one. So 2x divides x is 2. Now we multiply. 2 times x is 2x. 2 times 1 is 2. And then we subtract. Just be very careful there with subtracting. 2x minus 2x is 0. Negative 4 minus 2 is a negative 6. You have to be careful with that. So it's a negative 4 minus 2. So my remainder is negative 6. How do I write that? Well, your answer is x plus 2 remainder negative 6 over x plus 1. So look at that and then look back at the first example that I did. We write the remainder over the divisor. You don't have to know dividend divisor. So negative 6 over x plus 1, the same way we did in the first example, the remainder of 2 gets written over 4. All right, let's try another one. So we've got a polynomial that's cubic divided by a polynomial that is linear. X plus 3 we call a linear polynomial. If you were to graph that, it would graph to be a line. So it says, what is P of X divided by D of X? So that means we're going to set it up. X plus 3 divides into X cubed plus 5X squared plus 6X plus 9. Okay, so I'll walk through the process again. Again, the reason I gave you Delta Math for tonight was you can use his videos to help support what I'm teaching you in class right now. So remember, this is going to divide into this. It's always the first term divides into the first term. Or you can think of it as x cubed divided by x. And that's going to give me x squared. And now you multiply x squared times x, x cubed. X squared times 3, 3x squared. What do? We subtract, just like normal long division. So x cubed minus x cubed, 0. 5x squared minus 3x squared, 2x squared. Now we're dividing into that, and we're bringing down the next term. Actually, I should color the whole thing so that we remember that we're dividing into that. So 2x squared divided by x is 2x. Multiply. 2x times 3, or x is 2x squared. 2x times 3 is 6x. Subtract. Well, when you subtract, you get 0. But when you bring the 9 down, that's a remainder because x doesn't divide into 9, right? And so your answer is x squared plus 2x remainder 9 divided by x plus 3. So you're always going to write your remainder as what you have left, 9, over what you're dividing into, so the x plus 3. That is polynomial long division. And if you look back on here, they kind of step you through it, right? And also, you'll have this video to look back at and videos on Delta Math. Okay, so let's do let's do number 2. All right, actually, let's not do number 2. Let's do the U try. Okay, so x squared, I'll do one more, minus 4x plus 3 divides into x cubed minus 6x squared plus 11x minus 6. I might have to do that other one too, depending on, I want to talk about when terms are missing. Okay, so this guy divides into this guy, right? So x cubed divided by x squared is x. That's going to give me x cubed minus 4x squared plus 3x. I think the hardest part here is doing the subtraction. So x cubed minus x cubed is 0. Negative 6, subtract a negative 4. Now think about that. If you're subtracting a negative, you're adding. So that's really negative 6 plus 4, which is negative 2x squared. 11 minus 3 is 8. And then you bring down the minus 6. Okay. So again, now we're looking at that first term and this first term. So negative 2x squared divided by x squared is minus 2. So that's going to give me negative 2x squared plus 8x minus 6. And now we are subtracting. So a negative 2 minus a negative 2 is a negative 2 plus 2, which is 0. 8 minus 8 is 0. And negative 6 minus a negative 6 is negative 6 plus 6, which is 0. So this one divides in evenly. The answer is x minus 2. You can always check because you could take x minus 2 times x squared minus 4x plus 3 and get your polynomial. Okay, I was going to skip this one, but I decided to go back because sometimes when you're dividing, the entire polynomial in standard form has gaps. And in those gaps, you have to put like almost a placeholder when you're doing long division. Okay, so 2x plus 3 divides into 8x cubed, but then there is no x squared term. There is no x term, and then 27. So I've, in that place, put 0x squared and 0x. And I'm not sure if I gave you one of these on Delta Math or not, which is why I'm going over it. I have not altered the original p of x because 0x squared is 0 and 0x is 0. But you're going to see why it's necessary to put them in when we do the long division. Okay. All right. So 8x cubed. So let's just go back to our process, right? 8x cubed divided by 2x is 4x squared. And so we're going to multiply. 4x squared times 2x is 8x cubed. 4x squared times 3 is 12x squared. So now you have a place to put it under the placeholder 0x squared. Okay, draw your line, subtract. 8 minus 8 is 0. 0 minus 12 is negative 12x squared, plus bring the 0x down. Now we're going to divide again. So a negative 12x squared divided by 2x is minus 6x. Multiply, and you're going to get negative 12x squared minus 18x. And again, you have a placeholder of 0x, so you have its like term below it. Subtract. Negative 12 minus negative 12, 0. 0 minus a negative 18, 18x. Last one. Take 18x and divide by 2x and you get 9. Multiply and you get 18x plus 27. Subtract and you get 0. So your answer is 4x squared minus 6x plus 9. Now, maybe you already knew that, right? Because if I asked you to factor 8x cubed plus 27, which hopefully you did that in the homework, that is the sum of cubes. 2x plus 3, 4x squared minus 6x plus 9. Remember the pattern? And so we just proved why that pattern exists. Because when you take 8x cubed plus 27 and you divide by 2x plus 3, you get 4x squared minus 6x plus 9. Okay. Slide 5, synthetic division. Now, I always start with long division because it's the most tedious. Synthetic division is the smoothest, and it's the one that you will use most. Okay. So here's the steps for synthetic division in case you need to look back. All right. I'm not going to explain them until I actually do a problem with you. Okay. All right. So we are on slide 6. All right. Synthetic division is a technique used, right, to find factors and zeros of polynomials. All right. You can only use synthetic division when you are dividing by linear factors where the coefficient of x is 1. So it's really important in that box where it says synthetic division can only be used for factors of the form x minus k. Yeah, only x minus k, right? So there can't be a coefficient in front of x, right? And it has to be a linear term, meaning not x squared, x cubed, whatever. Okay. So You take this, right, which is x minus k, right? And this number, so you're not focusing on the that negative, but if I asked you what the 0 was for x minus 3, you would say 3. So if x minus 3 is the factor, the 0 is 3. Let me write that down. If x minus 3 is the factor, the 0 is 3. That's what goes in a box. So synthetic division is all about a process, all right? That's what goes in the box. So if you look back here, you'll see the little box there, right? I flipped back to slide 5. So when you're dividing by x minus 5, the 0 is 5. 5 goes in the box, okay? What goes next to it are the coefficients of the polynomial, putting zeros in for any terms that are missing, just like we did in long division. So x cubed, the coefficient is 1. X squared, the coefficient is 2. The x term is missing. So I put a placeholder of 0 and then -4. Then we draw a line, and here is the process of long division. It takes, like some students have told me by 3 practices they get it. Others have told me by 5. Once you see the pattern, you will be able to do it, and it's super easy. We bring down the 1. So perk up if you're not listening to me, all right? And you're not paying attention, because here goes. You bring down the 1. You take the 1 and you multiply it by 3 and you place it under the 2. And then you add. Then you repeat the process. 5 times 3 is 15. You put it under the 0 and then you add. 15 times 3 is 45. You place it under the -4 and you add. What do those numbers mean? Well, let's go back to what we were doing originally. We were dividing, right? So my answer is a polynomial. So the 1, the 5, and the 15, they form a polynomial that is always 1 degree less than the original. So hopefully it makes sense to you that if you're taking an x cubed polynomial and you're dividing by an x polynomial, you're going to end up with an x squared. So 1x squared plus 5x plus 15 remainder 41 over x minus 3. Now you're probably like, why did you even show me long division then, if it's this simple to do the division, right? Well, look at some of the long division problems we did. They weren't all linear, right? That one example was a square, a quadratic into a cubic. So sometimes you can't use synthetic division, all right? Let me show you another one, all right? So x to the 4th minus 10x squared. And again, this is all these steps are here. The one thing about this graphic is it tells you exactly, I went back to slide 5. It tells you exactly the steps, right? So you take 1, you multiply by 5, you put that number under the -2, you add. You take that number, you multiply by 5, you put that number under the -8, you add. So just know that the graphic is here to help you, okay? All right, so let's go back to the second example now, all right? So if x plus 3 is the factor, then -3 is the 0. And what we do is we say, put it in the house. Put -3 in the house. So you can think of that little box there as the house. Write your coefficients. X to the 4th has a coefficient of 1. X cubed is missing. So we have a 0 placeholder. -10 is the x squared. -2 is the x, and 4 is the constant term. All right. We draw our line for synthetic division. We bring down the first number and we begin the pattern. 1 times -3 is -3. Add -3. Multiply. -3 times -3 is 9. Put it under the -10. Add -1. -1 times -3 is +3. Add. You get 1. 1 times -3 is -3. You get 1. Sometimes I check myself to just make sure that I haven't made any mistakes. So 1 times -3 is -3. Add 9, add 3, add -3, 1. Okay, what's my answer then? Well, if I'm taking an x to the 4th and I'm dividing by an x, so what I'm looking at is the first term of the polynomial on top and the first term of the factor on the bottom. I know I'm going to end up with an x cubed. And so my answer has to be x cubed, 1x cubed, minus 3x squared, minus 1x plus 1, remainder 1 over x plus 3. Now, I just did 2 examples with you where you have a remainder, right? If you don't have a remainder, then you found a factor. Like you divided, and that would mean that -3 is the 0. So I want to ask you a question, and you can just think it in your head. In both of these examples, I wrote the 0 is 3 and the 0 is -3, when in fact, they weren't zeros. All right. So I want to go back to that. 3 is not a 0 because there is a remainder. And over here, -3 is not a 0 because there is a remainder. It's only going to be a 0 if you end up with 0 for the remainder. So let's look on the next page, okay? Let's look at, I'm on slide 7 now. I'm on slide 7, okay? Wait, isn't it the one we just did? 2x squared minus 2x plus 4. Okay, we just did that one. So let's look at this one. So x minus 5 is my factor. Well, possibly, right? So that means we're going to put 5 in the house. And we're going to write 3, -17, 15, and -25. Okay? No missing terms there. X cubed, x squared, x, and constant term. Bring down the 3. 3 times 5 is 15. Put the 15 under the -17. -17 and 15 is -2. And then we start the process over again. -2 times 5 is -10. Add, you get 5. 5 times 5 is 25. You put it under the -25, and now we get a remainder of 0, which means that 5 is a 0. So 5 is a 0 because the remainder is 0. Okay. And so my answer to the division problem is 3x squared minus 2x plus 5. And there's no remainder. Now, how does this tie in to what we're doing? Okay. So now I've shown you long division and I've shown you synthetic division. All right. Now it says, why do we need them? Right? So I'm on slide 8. So now I'm going to pull it all together for you. I'm on slide 8. Right? So imagine that this is the type of question that you're going to have on an assessment. And it says, what are all the real and complex zeros of the polynomial function shown in the graph. So I'm looking at the graph, right? And below the graph is the equation of the polynomial. I know it's cubic, all right? So my degree is 3, okay? That means 3 zeros, right? But I only see one of them on the graph. X equals 2 is 1, 0. There are 2 more. They are not on the graph, which means they are complex zeros. They are non-real. And so now I have to have a method for how to find them. And this is where synthetic division comes in. We know that 2 is a 0. So I'm going to put 2 in the house, and I'm going to put my polynomial next to it, my coefficients. So that's 1, 1, -3, -6. Here goes synthetic division. Bring down the 1. 1 times 2 is 2. 2 plus 1 is 3. 3 times 2 is 6. -3 plus 6 is 3. 3 times 2 is 6. And yes, I better get a remainder of 0 because I know from looking at the graph that 2 is a 0. What do I have left? Well, I have a quadratic, x squared plus 3x plus 3. Does it factor? No. If it factored, we would see those zeros on the graph. And so we have to use the quad formula to find the remaining zeros. Okay, so let's do that. X equals, now you see why I had you do quad formula with your delta math. Hopefully you practice those. So opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to be -3 plus or minus the square root of 9 subtract 12 is -3 over 2. What do we do with negative under the square root? We simplify it to I. So this is going to be x equals -3 plus or minus I root 3 over 2, which is x equals -3 over 2 plus or minus I root 3 over 2. And then my other 0, x equals, what was it? 2? I forgot it already. 2 off the graph. And so now you see where synthetic division ties together with what we've already been doing, finding all the zeros of the polynomial. Up until now, you just typed your polynomial into Desmos and you just clicked, on the points and found their locations. But now some of our zeros are going to be non-real. Okay. All right. Slide 9, our last slide. Okay, I'll do one more example with you. So pull all your focus together and watch me do the last one. Okay. So looking at the graph, first of all, the degree of the polynomial is 3. Okay. The degree is 3. Looking at the graph, I can detect one of the zeros is at 3. Okay. So 1, 0 at 3. Okay. So 1, 2, 3. So I'm going to put 3 in the house, right? And then I'm going to put the coefficients from the polynomial next to it. Okay. So that's going to be 2, -8, 9, -9. Here's synthetic division one more time. Bring down the 2. 2 times 3 is 6. 6 and -8 is -2. -2 times 3 is -6. add 3. 3 times 3 is 9, add 0. When you know that a number is a 0 of the polynomial, you will always get this remainder of 0. If you don't, you did something wrong with synthetic division. Okay, so what's left is my quadratic, 2x squared minus 2x plus 3 equals 0. And then I'm going to go ahead and solve it. So x equals the opposite of -2 plus or minus the square root of b squared. That's 4 minus 4 times 2 times 3 all over 2 times 2. And it's good that we did quadratic formula last semester, so it should just be a review skill for you right now. 2 plus or minus the square root of 4 subtract 24. So that's going to be -20 over 4, right? 4 times 2 is 8. Yep. So now I'm probably going to come over here then and just break down the square root of -20. That's going to be the square root of -4 times the square root of 5. So that's 2i root 5. Okay, so x equals 2 plus or minus 2i root 5 over 4. And that's going to be 2 over 4 plus or minus 2i root 5 over 4. And that's going to be 1 over 2 plus or minus I root 5 over 2. So my zeros are 2 complex and 1 real. Now, what you're going to notice as you do this is your complex zeros always come in pairs, as do your irrational. If you go to use the quadratic formula, you are always going to end up with 2 zeros, okay? And they are called complex conjugates. So you will always have them come in pairs. So if your polynomial is cubic and you have one real and you are looking at the graph, those other two, and you don't see anymore, they have to be non-real and they come in pairs. Okay, so I'm going to put aside my iPad. I'm going to stop sharing. All right. Why doesn't everybody come back to me? So put your cameras back on.